Good day, learners. Welcome to today's lesson. I hope you are all well prepared. For our previous lessons, we were treating the topic properties of polygons, where we looked at the types of a triangle, such as an equilateral triangle, which has all sides equal, an isosceles triangle, which has two sides equal, and a scalene triangle, which has none of its sides being equal. We also looked at finding the sum of interior angles of a regular polygon, which is n minus 2 times 180 degrees, and an interior angle given by n minus 2 times 180 degrees all over n. Also, the sum of exterior angle, which is 360 degrees, and an exterior angle given by 360 degrees over n, where n is the number of sides of the regular polygon. In today's lesson, we'll be looking at the Pythagoras theorem, and by the end of this lesson, you will be able to use the Pythagoras theorem to find the missing sides of a right angle triangle given two sides. Now, let's look at the things that makes a triangle a right angle triangle. A triangle is said to be a right angle triangle when one of its interior angles is 90 degrees. It can be an isosceles triangle or a scalene triangle. Now, let's look at the various orientations of a right angle triangle. Let's also look at the various parts of a right angle triangle. When given a right angle triangle, the side facing the 90 degrees is called the hypotenuse, and it's always the longest side of the right angled triangle. The other two sides are called the adjacent sides if no other angle is given. When an angle is given, then the side facing it is called the opposite side, and the other the adjacent side. Let's try these activities. In few seconds, which of the following sides of the triangles are the opposite sides? Well done. I believe you had A to be the opposite side of triangle A, M to be the opposite side of triangle B, and G to be the opposite side of triangle C. Now, let's perform some practical activities to establish a relationship between the sides of the right angle triangle. The materials needed are manila cards, a mathematical set, a curtain, a paper glue, a marker, and a pair of scissors. With the help of a ruler and a pair of compass, we will construct a right angle triangle using a suitable measurement. Okay, now we have our right angle triangle. Using the length or sides of the right angle triangle, we are going to cut out 3 different squares from our manila cards. Now, we have all 3 squares. Let's arrange the squares around the right angle triangle to see whether it fits. Perfect. it fits. We are going to cut and arrange these two squares on a bigger one to see if it covers its whole area. But before that, let's find the area of all the three squares. Now, we are going to cut and arrange these two squares on a bigger one to see if it covers the whole area. Wow! It covers the whole area of the big square. What does this tell you? The area of the bigger square equals the sum of the areas of the smaller squares. This brings about the Pythagoras theorem, which states that the square of length of the hypotenuse equals the sum of squares of the other two sides of the right angle triangle. Let's solve an example. Given A equals 9 centimeters and B equals 12 centimeters, what will be the value of C? We have established from the Pythagoras theorem that C squared equals A squared plus B squared. So therefore, C squared equals 9 squared plus 12 squared. And then C squared will be equal to 81 plus 144. C squared will also give us 225. Finding for C will be the square root of 225, giving us 15 centimeters. Let's try this second example. From the Pythagoras theorem, we know that C squared is equal to A squared plus B squared. And from the question, A equals 3 centimeters, C is equal to 5 centimeters, and we have to find B. Now, we substitute A and C into the equation. We make B the subject, where B is equal to the root of 16, and B will give us 4 centimeters. Pause the video and try the other two examples. Let's see how this theorem can be applied in our daily life. Considering a real-life application, a mason has a ladder of 250 centimeters long and would like to get to the top of a wall of height 200 centimeters. How far would the foot of the ladder be away from the base of the wall? Using the Pythagoras theorem, C squared equals A squared plus B squared. Taking A to be the height of the wall, C to be the length of the ladder, and then B to be the distance of the foot of the ladder from the wall. We then substitute the values of A and C into the formula and make B the subject. We then get B to be 150 centimeters. And that becomes the distance between the foot of the ladder and the base of the wall. In today's lesson, we have covered the fundamental concept of Pythagoras theorem, including the properties, the formula, and the application. By mastering the Pythagoras theorem, you will not be only improving on your problem-solving skills, but also develop a deeper appreciation for mathematics. Thank you for watching. See you in the next lesson. Bye-bye.